Hi class, so now for statics of rigid bodies, we are now in equilibrium. So since we've discussed already about forces, about moments, different types of supports and their corresponding reactions, we've also talked about the loadings, different types of loadings, and free body diagrams. So with all these topics, we are now ready to analyze a whole system or a whole structure. So when we analyze structures, definitely we want them to be stable. That means that they must not move and they must not rotate. So this motion or this state na no motion is what we call equilibrium. So equilibrium, so bodies in equilibrium. A body is said to be in equilibrium if the resultant of the force system that acts on the body is zero. So yung mga forces, resultant nila are counteracted kaya nagsi-zero lahat. And then that also means the same sa mga moments. Lahat ng applied moments may counteraction kaya nagsi-zero, nakabalance sila. So equilibrium means that both the resultant force and couple are zero nga. So this means that we want our structures nga to be balanced so that there will be no excess applied load. Kasi kapag may excess na applied load na hindi na counteract, this will cause of course instability or motion. Magmo-move or rotate yung structure natin. So this means applied loads are counteracted by our, of course, yung mga supports. Sila yung nagpo-provide ng reactions para ma-counteract ang applied forces or loads. So, translational equilibrium. So, this is, sabi niya, the sum of all forces or yung resultant force acting on the body is zero. So, kapag ang resultant ng lahat na applied force na counteract, edi magzi-zero. But what will happen kapag hindi? That is, for example, itong nasa figure natin. Meron tayong applied na load na 10 Newton. It is not counteracted. So, what will this load do to our vertical body? It will cause horizontal translation to the right since the force is directed towards the right. So, it will cause movement or horizontal translation to the right sa body natin. And then, what is rotational equilibrium? So, if the sum of all the moments acting on the body is zero, this also means all the moments na applied are counteracted by the supports. That's why it's zero. So, what happens if there is a resultant na moment? There is excess or net moment. So, for example, on our figure, our body here, so it is acted by a 10 Newton load na which has a distance from the floor. So, the floor is the support. Our body rests on the floor, no? So since our force has a distance 3 meter from the support, what will happen? What do that mean? So it means we have moment because moment is force with a distance from your fixed point or your support point or point or evaluation. So meron siyang moment, that means we have rotation. So moment, excess moments cause rotation, excess forces cause translation or movement. So if you see from our figure here, our applied force 10 Newton, it acts directly on the floor or our point of support. So there's no distance, we don't have moment for this example. But with this second one, we have a net force. We have excess force not resisted. We also have moment. That's why the cause of these two, the excess force and the excess moment, is horizontal translation and also a clockwise rotation. So for our next slide, so this is an example of a system, this one. So this is an example of a system. This is a hook. So it is unsupported. There's no support. It is free to move. This hook is also acted by two forces, force 1 and then force 2. So these are applied force, and our hook is not supported, so it has no reaction, support reaction. It means this will have a resultant force, and that resultant force will cause this hook, of course, to move. So how do you know saan ang movement niya, where it will go? It will depend on the resultant force. So how do you get the resultant force? This is our lesson last topic before. So you get yung summation of forces along x. So it horizontal component of the force 1 and then horizontal component of force 2. Then you get this 236.n Newton to the right. So it means the resultant of these two forces along x-axis is going to the right. And then to get the resultant along y-axis, you summation the forces along y-axis. So y component of this load is this one, and then y component of the 400 Newton load is this one. So our resultant is an upward force with a magnitude of 582.8 Newton. So to get the resultant of these two x and y forces, we use Pythagorean theorem. So this is, we get 629 Newton. That is the magnitude of the resultant, which is this one. And then, how did we know na this is how it is directed? It is by getting the theta. And with the tangent formula, we are able to get theta, and it is 67.9 degrees. So, by this topic before, we are able to know the direction of the motion of this hook na. It is by getting yung force and yung angle of our force. So, since we have a resultant force, magmo-move yung hook natin pa ganyan. Okay? Because it's not resisted. But what if we put support on our free hook? We anchor it on this surface by a pin. Ito siya. So it is now supported. Now we are able to counteract the resultant force. So I've taught you this. Since this is a concurrent force system, we can simply do manual observation to get yung reaction of our support. So by getting the opposite of this FR, opposite direction but equal magnitude, that is your reaction, the reaction of your support. No, let's call R, that is your reaction. And then how do you know its angle? It is, of course, equal to the angle of your resultant. So if this is theta, if it is 67.9, this is also 67.9. Basta oppositely directed sila. So that is the reaction of our support. And it is balanced. It is able to counteract the force FR. So we can apply the equations of equilibrium here, because summation of forces along x will be equal to 0, since if you get the horizontal component of the reaction and the horizontal component of the resultant force, they will minus each other. They will subtract. So your summation along x is equal to 0 nga. And then if you do summation along y equal to 0, of course, magzi-0 siya, because the vertical component of the resultant force is equal to the vertical component of our reaction. So magzi-0 talaga ito. So that what means by equilibrium equations natin. You want the system to be balanced by uh, counteracting completely yung applied force natin or resultant force by the reaction of our support. So that was for concurrent force system. How about dun sa mga coplanar force system? So, example of a coplanar force system is yung mga beams natin, trusses, frames, those are examples of coplanar force system. The system acts on a plane. So, for example, our body, so it has length already. So, this is a coplanar system. So, here is our bar. So, we have a bar OP. So, it is homogeneous and it is a rigid body. Since this is a homogeneous material, we expect its center of gravity to be at its middle or centroid niya. So, if this is 10 meter, so center of gravity to point O is 5 meters, and then center of gravity to point P is also 5 meters. So, what will happen to this body if we apply a 15 Newton force downward na ganyan? So, take note, this body don't have support, okay? No support. It only has a center of gravity. And since our 15 Newton force passes the center of gravity, it means there will be no moment. So, no moment, wala tayong rotation. But what happens is, we have a force which is not counteracted since wala tayong support. So, ibig sabihin, it means our body will move from this point downward since our 15 Newton force is directed downward. So, there is vertical translation. So, example or figure number 2, we have body OP again, but our applied load is 3 meters from the center of gravity. So, this means we have moment because our force acts 3 meters from the center of gravity. Take note again, this body don't have support again. So, our reference point is the center of gravity. So now, our 20 Newton force, it acts 3 meters from the center of gravity. So that means this one already have moment. And that moment is equal to 20 times 3 meters. So the moment is not counteracted since we don't have support, and also the force is not counteracted since we also don't have support. So our motion is a vertical translation with rotation pa. So the body will move downward, so bababa siyang ganon, and then magro-rotate pa siya. So what is the rotation? It is counterclockwise, so it will rotate counterclockwise. So, vertical translation and also a counterclockwise rotation. So, again, on the third figure, body OP again. So, this is our bar. And then, it has the same center of gravity. So, the same bar siya. But this time, we have two forces. And then, they don't have equal magnitude. One force is 20 Newton, the other is 10 Newton. And then also, their distance from the center of gravity is 3 meters for 20 Newton load. And then for this 10 Newton load, it has a distance for 4 meters. So, unequal. So, how do we know ano yung resultant moment? So, that is by siyempre, summation of moment. Siyempre, saan tayo magsasummation ng moment? We summation moment at point of center of gravity. Since 20 Newton load will cause a counterclockwise rotation, and then the 10 Newton load will cause a clockwise rotation. So, let's see if this system is in equilibrium or if there is excess moment. So, of course, yung vertical forces, exist na agad yan. What is our resultant vertical force? Since they are both downward, additive sila. So, negative 20 and then negative 10 at the negative 30 downward. That's our resultant vertical force of applied loads. So, meron kang 30 Newton. So, this will cause movement, vertical translation. And then, so, ayun, we have vertical translation. So, do we have rotation? So, let's check if we have rotation. Let's balance about the center of gravity. So, summation of moment at center of gravity is, so 20 Newton times 3 meters. It is positive since counterclockwise. And then the 10 Newton load, it is 10 times 4 meters. Then negative siya since it's clockwise. So, what's the result? 20 times 30 is 60 minus 40. 10 times 4. So, this is 60 minus 40. So, we have a positive 20 Newton meter excess. So, this excess, it is not counteracted. So, our bar OP is not in equilibrium. It will rotate. What? Ano ang rotation niya? Since the excess, the excess moment comes from this, the counterclockwise, no? So, our rotation is counterclockwise. So, counterclockwise rotation ulit tayo. With this magnitude, 20 Newton meter rotation. So, it is not balanced. The next fourth figure, nadagdagan, we have additional force. So, you will do the same to check if it's balanced or not. Summation of forces along vertical, and then summation of moment at the center of gravity to check if my excess, and that excess will cause movement or rotation. But of course, let me erase muna. So that's the point of equilibrium. We want them to be balanced, and we don't want excess na forces. We want all forces to be counteracted. So let's make these unbalanced systems into balanced one. So for figure 1, how do we make this balance? Of course, counteract the force. Our excess here is just the 15 Newton force, diba? We don't have moment. So the support that we shall provide should be capable of 15 Newton. So our support shall give a reaction of 15 Newton upward to counteract our 15 Newton downward applied load. And then for figure number 2, how do we make this balance? Counteract mo din to, 20 Newton with the same distance na 3 meter. Counteracted both the force and the moment. And then dito sa figure 3, counteract mo siya. Counteract mo din to. So, no moment, no excess force then. No excess force, no excess moment. The same with this one. So, mukhang it looks easy, no? Pero, in real life, we cannot do that, balancing. Because our supports, these supports, have their specific location along our beam. For example, we have this beam. Of course, yung reactions natin will occur at the support. And then we have various loadings na. Unlike sa example natin, we just counteract directly sa point ng application ng mga applied in real life, sa beam natin, we cannot do that. May specific location ang mga reactions natin. So, what do we need to solve for that? It is yung three equations of equilibrium. So, these three equations of equilibrium will balance our structures. So, ito yung our three equations of equilibrium are summation of forces along the horizontal must be 0, summation of forces along the vertical should be 0, and summation of moment at any point of the structure should be 0 at any point. So, that point is the point of supports, na? If you have this structure, and then if you say that this structure is in equilibrium, so it means if you take moment at this point, it should be balanced, is still equal to 0. And if you take moment at this point, it should still be equal to 0. So, from our last figure, this was our last figure, no? How do we put supports on our beam? We can put different kinds of support, depende sa engineer. Depends on the engineer. Depends on the situation, what type of structure. So, ganon. So, this is, on this side are the different types of support applied on our beam OP. So, we can put hinge support or roller support dito, or we can also put hinge support and then frictionless support on the other side. Then we can also put two cables to support our beam at each end, or we can put one hinge dito and then the other is a tension cable. No? So, ropes and cables, sabi nga natin, they carry tension loads only. They cannot carry compression. So, let's try to get the reaction forces dito. So, each type of support have their they have their own corresponding reactions to provide, diba? So, for hinge support, what's the reaction it can give? It can give vertical and horizontal reactions. And then for roller, it can give normal reaction. So, ibig sabihin, if the surface where you put the roller is flat or horizontal, the force it can give you is vertical. Because we are maintaining perpendicularity between the surface and our reaction of the roller. But if the roller is placed on an inclined plane, say this is 30, so what will be the diagram of our support reaction at point P? Siyempre, this will be our support reaction for the roller because we keep this perpendicular. Ganun si roller. It can only provide one reaction, and that reaction, the direction of that reaction depends on the surface where you rest your roller. Okay? And then ganito muna siya. It rests on a horizontal plane, so vertical C. Reaction at point P. And then the same with this, hinge will give you vertical and horizontal reactions. And then for this one, for friction or frictional surface, so this also gives you vertical reaction. We also keep this perpendicular with the surface. So what's the difference between this type of reaction and a roller reaction? A roller reaction can give you upward or downward reaction. Whereas if you use this friction type of support, yung surface lang, you rest the beam on a surface, it can only give you this type of reaction. Hindi, it cannot give you a reaction na ganyan. Cannot give you downward reaction, only vertical. Ay, ba't ganun? Can only give you vertical. Okay? This is perpendicular to the surface, and yung arrowhead always pointing towards the surface of your surface. You cannot go down from the face of the surface. Na? Okay. And then tension. What is the reaction tension materials can give? It can only give you tension forces, tension load, tension reaction force. Pag ganyan lang. It can never be compression because ropes cannot compress. They can only carry tension loads. And then on our fourth figure, dito naman, of course, vertical and horizontal. And then may tension siyang reaction dito. Support reaction. Okay? So that's how we draw the reaction of different types of supports. So let's have an example so we can further understand. So let's get yung example, the beam with a hinge and roller support. Hinge at point O, roller at point B. Okay. So let's get the reactions of these supports. Reactions for hinge is vertical and horizontal. Let's name this RO vertical, RO horizontal. And for the roller at point P, our surface is horizontal. So our reaction is vertical, perpendicular to the surface. So let's name this RPV. Reaction at point P, vertical. So we need to find these three. So using the three equations of equilibrium, summation of forces along vertical equals 0, summation of forces along horizontal equal to 0, and summation at point O equal to 0. Or if you want P, you can also use point P, use summation moment at point P equal to 0. So either of the two you can use. So all equal to 0. So we're going to find these three, their values wherein the system will be balanced. So let's start. Summation of forces along vertical muna tayo. So all equal to 0. So all equal to 0 equal. So let's start from the left. So ROV is upward, so positive ROV. Next load, 30 kilonewton negative. And then next load, 15 kilonewton negative. And then 60 still downward, so negative. And then RPV is upward, so positive RPV. So we have two unknowns. So put aside muna natin to, and let's name it equation number 1. Equation number 1 to, and then summation of forces along the horizontal all equal to 0. So makikita ninyo as you can see, In the equations of equilibrium, we combine the loads, given loads, or the applied loads versus our reaction. Because we're trying to make them balance nga, di ba? It is the forces, applied forces versus the supports. So, summation of forces along horizontal are all equal to 0. And actually, along the horizontal, you don't have horizontal applied force. So, anong mangyayari? Our horizontal reaction dahil sa point O or support at O is equal to 0. And then next equation of equilibrium is summation of moment. So let's do summation of moment at point O. Since sanay tayo, we're used to solving on the left side naman na. So summation of moment, point O equal to 0. So since we're evaluating point O, all forces that passes point O will be disregarded. And what are those forces? Are OH yon and ROV. So they are not included sa summation of moment at point O. So equal to 0. So what are the forces involved only? It is 30, 15, 60, and RPV. So what's the moment arm of the 30 Newton force? 2.67. And then what's the direction of their rotation? It is clockwise with reference sa point O kasi, di ba? So clockwise, so negative 30 times the moment arm na 2.67. And then next load is 15, is still clockwise, so negative 15 times the moment arm, which is 6 meters. And then next load is 60, so rotation direction is still clockwise, so negative 60 times moment arm na 7 meters. And then next na load is RPV, and then ang direction of rotation is counterclockwise, so positive RPV times the moment arm is 7 plus 3, so that's 10 meters. So with these equations, we only have one unknown, which is RPV. So we can isolate RPV. RPV is equal to, let's move all these terms to the opposite or to the other side of the equation. So magiging positive na sila on the other side. So that will be 30 times 2.67 plus 15 times 6 plus 60 times 7. And then, to isolate RPV, you need to remove the 10 meters by dividing both sides by 10. Okay, so our RPV is equal to, let me calculate, 30 times 2.67 plus 15 times 6 plus 60 times 7. Denominator is 10. So, 59.01. 59.01 unit is kilonewton. So, this is our PV. Now, we can get our OVs using equation 1. We can substitute our PV here so that ROV is the only unknown in this equation. So we can isolate ROV. So lipat natin to the other side of the equation. So magiging positive. That is positive 30 plus 15 plus 60. And then ito magiging negative. Negative RPV. So this will be 30 105 minus 59.01, so it is 45.99 kilonewton. So that is our ROV. Let's check if what we got are correct. Okay, so how do we know? It should be summation of forces. If you substitute them, try substituting them sa equation, it should be equal to 0. Or do the applied for applied forces versus reaction of the supports. So applied forces, since downward silang lahat, so 30 plus 15 plus 60, this is equal to 105 versus, so the sum of these two should be 105 para counteracted, di ba? So 59.01 plus 45.99 should be equal to 105. So it is equal sa 105. And this is positive, this is negative, so counteracted sila. So our system is balanced. Then you can also substitute dun sa summation of forces. Try doing, if you want to check your result, try doing summation of forces on the other point. It should be equal to 0 pa din. So let's do that for checking. Let me erase first. Ay, ba't ko in-erase yung... Ito lang. Ay. Okay. To check, let's do summation of moment. Point P should be equal to 0 kasi balance. So, dito, our point of evaluation is point P. Should be 0. So, let's start. Papuntang from the right to the left tayo. So, start with 60 kilonewton positive since counterclockwise. So, 60 times its moment arm is 3 meters. And then next, 15 kilonewton, still positive dahil counterclockwise. Moment arm is, ano bang moment arm nito? It is, 4 meters, no? This is 10 minus 6, diba? So, 4 meters. Let me just put that, 4 meters to. 4 meters. From this point to that point, 4 meters. The next na load is 30 kilonewton, still counterclockwise with reference sa point P. So, positive counterclockwise times, ano ang moment arm niya? This is, total kasi nito, diba, is 10 meters. How do we know that? 7 meters to 3 meters yan. So, 10 meters, minus natin si 2.67. Yun ang moment arm ng 30 kilonewton. Okay, and then next load, of course, si ROV. Ano ang direction ng rotation? Clockwise. So, negative ROV. Ano ang kanyang moment arm? It is 10. So, with this equation, we only have one variable or we only have one unknown, which is ROV. So, isolating ROV, so, negative siya dito. Let's move it to the other side of the equation. So, positive na siya doon. And then, let's calculate this. 60 times 3 plus 15 times 4 plus 30 times the quantity 10 minus 2.67. So, it is equal to 459. Wait lang. 459.9. And then, divided by 10. Because ROV, because it has 10 numerical coefficient, it is with this 10. So, to isolate it, you need, di ba, ganyan yan, you need to divide each side, both side, by 10. para ROV is isolated. Cancel, cancel. And for this one, do the operation. For 59.9 divided by 10, it is 45.99 kilonewton. So this is ROV na. Is it the same with the ROV we got in the first solution? Yes, no? 45.99 equal to 45.99. ROV and ROV din dito. So our system or our structure is balanced. So let's try this system. It is the same beam, not really the same beam because this one have a different support. So point P is free, it's a free end, and then point O is a fixed support. So what did we say about fixed support? Fixed support, they can carry vertical. Hindi nagsulat. Fixed support can carry vertical, horizontal, and moment reactions. So let's name them ROV, ROH, and MO, moment point O. So let's do summation of forces along horizontal. So syempre, summation of forces along horizontal equal to 0. We don't have any load along the horizontal. We don't have any applied load. So we don't have any load to resist along the horizontal. So ROH is equal to 0. And then summation of forces along the vertical equal to 0. So let's start from the right. What is our first vertical load? Syempre si ROV. So equal to 0 sila. ROV is upward, so positive ROV. Then next load is 30 kilonewton downward, so negative. Then next, negative ulit since downward si 15 kilonewton and 60 kilonewton is also downward, so downward. So with this equation, we have only one unknown, which is ROV. So let's isolate ROV. Transfer these three terms to the other side of the equation. So isolated C ROV. So ROV is equal to 30 plus 15 plus 60. And that is equal to 30 plus 15 plus 60. 105 kilo. 105 kilonewton, si ROV. Then next, summation of moment should be equal to 0. Summation of moment, point O should be equal to 0. So what is the first moment from the left? Of course, it's MO. Counterclockwise, so it is positive MO. And then 30 kilonewton with reference sa point O, it is clockwise, so negative 30 times moment arm 2.67. And then 15 is still clockwise, so it's negative 15 times moment arm is 6 meters. And then 60 kilonewton is still clockwise, so negative for clockwise, and then moment arm is 7 meters. So let's isolate MO. MO is the only variable in this equation, so we can get MO. So transfer the three terms to the other side of the equation, so they will become positive. And we were able to isolate positive MO. So let's rewrite the equation. MO will be equal to positive 30 times 2.67 plus 15 times 6 plus 60 times 7. How much is this? So perform the operation. 30 times 2.67 plus 15 times 6 plus 60 times 7. That is equal to 590.1 kilonewton per meter. That is your MO. That is your fixed supports resistance against the moment created by the three forces. Okay. So let's have some more example. Let's keep these structures in equilibrium. So we have the beam, the homogeneous 120 kilogram wooden beam is suspended from ropes at A. So we have rope at A and rope at B. So a power wrench applies a 50 Newton meter 50 applies a 500 Newton meter counterclockwise couple or moment to tighten a bolt at point C. So use the given free body diagram. Anyway, so let's analyze. So what are our supports? So we have ropes at point A and B. And what did we say about ropes? They can only provide tension reactions. So if we draw the free body diagram of this beam, so eto siya. We have point A. We have point A. We have point B. And we have point C. Let's write the dimensions or distances. This is 4 meters and this is 2 meters. Okay, then how do we draw the applied loads? First, what is our applied load? Of course, we have the applied couple or applied moment. It is counterclockwise applied at point C, 500 Newton meter. And then the problem stated that the beam is homogeneous and it has a mass. Since in kilogram is a unit of mass. Sorry. So it has a mass of 120 kilogram. So first, we have the word homogeneous. So it means at the center is yung center of gravity natin. And this center of gravity is the location where weight occurs or applied. So how do we get the weight? We will consider the weight because, of course, the problem stated that the wooden beam has a mass of 120 kilogram. So how do we get the weight? It is yung mass times the gravity. Since kilogram is an SI unit, of course, you will use the SI value of gravity, which is 9.81 meter per second squared. So our mass is 120 kilogram. So SI unit to. This is actually equal, if you put them together, this is Newton. Newton is kilogram times meter per second squared kilogram. Okay? So let's get the weight. So our weight na is equal to, our mass is 120 kilogram. Our gravity is 9.81 meter per second squared. So our weight is 120 times 9.81. So it is 1177.2 Newton. Kasi nga, kilogram times meter divided by second squared is Newton. Ito yan. Okay, so we have weight acting at the center of gravity. Of course, lagi naman ng weight now. It acts sa center of gravity. So if you put dimension, if you will locate the center of gravity, it is the total length divided by 2. So 6 divided by 2, it is 3 meters from here and 3 meters from the other end. Okay, so let's put a point for the weight. And the weight is nandito. It is 1177.2 Newton meter. So now we already drew the applied loads, no? So next, how are we going to draw the reactions of the supports. So since we have tension, we have ropes, they can only provide tension reactions. So tension lang yan. So to draw a tension force from the point of application, the arrowhead will point away from the point of application. That's tension, no? Okay, tension upward since nasa taas ang ropes natin. So this is the free body diagram. Let me just draw it again, no? Para mas clear. So this is point A. And this is point B. This is point C. Let's add point D for the center of gravity. So let's put the load. Load at point C is the moment equal to 500 Newton meter. And then we have a weight of 1177.2 Newton. Oh, those are the loads. And then our supports, we have a tension here and a tension there. Let's name them TA and TB. So this is our free body diagram. Let me just isolate. Mama. So this is our free body diagram. So from this diagram, we are able to do the solution. So how do we solve? Of course, the three equations of equilibrium. Summation of forces along the horizontal. It is not required to do the summation of forces along horizontal since we don't have any applied load along the horizontal. So summation of forces along the horizontal is 0. So 0 lang. No applied force, no reaction force. Since our supports are only ropes, no? These ropes cannot provide horizontal reaction. So 0 lang. See? Summation of forces along horizontal. Next, you can do summation of forces along the vertical first. So let's do the summation of forces along vertical. So all equal to 0. So 0 is equal to, what are our forces? We only have 3 forces, TA, TB, and the weight. This couple or this moment, this is not a force, it's moment. So when you do the summation of forces along vertical or even horizontal, never include moments. So what are our vertical? So TA, upward, positive, and then upward also is TB, and then downward is the weight, which is equal to 1177.2 Newton. So in this equation we have two unknowns, so let us set this aside. Let's call it equation 1. Then proceed with summation of forces about point A. So point A na. So about point A, dito. So at point A, so all forces that passes through point A will not be considered. And that is TA. It passes point A. So hindi siya kasama sa summation of forces. So summation of forces summation of moment about point A equal to 0. So equal to 0. So from point A, our first load is the weight, 1177.2. The direction is clockwise, so it's negative. 1172. Ano ba yan? 1177.2 times the moment arm. The moment arm is, sabi nga natin, this is the center of gravity, which is the location of the weight. So this is 3 meters from point A. Then next force is TB na. TB has a counterclockwise direction, so it's positive. So TB, and then what's the moment arm of TB? So TB is 4 meters times 4 meters. And then we are summing up moments, diba? And one of our applied loads is a moment. So this one is included in our summation of moment about A. So what is our load? It is 500 Newton is the 500 Newton meter. What's the direction? Since as you can see, it is clockwise, so it's clockwise. It's negative. Do you need a moment arm to multiply to this moment? No. No. No na, no. Kasi it's already a moment. Look at the unit, it is Newton meter. So, may linear multiplied na sa kanya. You don't need to multiply any dimension or moment arm to a moment load because it's already a moment. Just consider yung sign niya. So now, this is our equation. Done na yung summation of moment natin. And we only have one variable, which is TB. So we can isolate TB. And then we are able to get the value of TB, no? So, move these terms to the other side of the equation, so magiging positive sila. Then TB is isolated, pero kasama pa niya, it is with 4 pa. So, you need to divide both sides of the equation by 4. So, let's write that. Write muna natin, 4TB equal, magiging positive na to, since ililipat na natin siya. So, positive 11772 times 3, and then positive na rin to, plus 500. Since kasama pa, it is with 4, we need TB alone, so divide both sides of the equation by 4, so cancel. TB is really isolated now. So then perform this operation to get the value of TB. So that is 1177.2 times 3 plus 500. Then all of this divided by 4. So our is 1007.9 Newton. Okay, same answer. So since we have the value for TB, we can go back to equation 1, this one, substitute the value of TB, which is 1007.9. So in this equation na, TA is the only variable. So isolate it to get the value of TA. So value of TA is, isolate natin siya. So 1172, other side of the equation, so it's positive. And then we will also transpose TB to the other side of the equation, so it will be negative. What's the value of TB? 1009 is the 7.9. So TA is 1177.2 minus 1007.9. It is 169.2. Okay? So, may discrepancy na 0.1, pero that's just due to, rounding off lang yan. That's okay. 169. So, we got the answer. And then, 1007.92. So, this, so this structure is now in equilibrium. Do you want to double check? You can double check by getting summation of forces on another point on the beam. Dapat should be equal to still 0. Let's try checking. So, we did summation of moment at point A, no? Let's do summation of moment at point B. And then use the values that we got to check if they are okay. So, the point is, dapat summation of moment at B is still equal to 0. As we've said, for the structure to be in equilibrium, there should be no excess force and there should be no excess moment at any point. So if you evaluate this point for moment, it should be equal to 0. If you evaluate B for moment, it should be 0 too. And then if you evaluate C, what should be the the answer? It should be equal to the moment at point C, because point C is not free of moment. It is 500 Newton meter. At point B, you don't have moment. Same with point A. So let's check. Let's do summation at point B. All equal to 0. So at point A, you have tension, point B you have tension. Okay? Nilinawan ko lang yon. So tension, and we're evaluating point B. So the direction of TA is clockwise. So negative TA times, what's the moment arm from B? Distance niya from B is 4 meters. And then TB, we will not consider point B since we're evaluating point B. We will not consider TB because it passes point B. So go to the next force or moment. It is 500 Newton meter. So what's the direction? It is also clockwise. Ayaw. It is also clockwise. So and then next, we have, don't forget the weight here. So, evaluating about point B, the rotation is counterclockwise. So, it's positive. Weight, what is the distance of the weight? Diba? This is 1 because this is 3 and this is 2. Okay? Why? Because the weight is at the center. So, 3 meters dito, 3 meters on the other side. So, 1 plus 2 is 3. Nakagitna siya. That's the weight. So, the distance of the weight to point B is 1 meter. Okay? So, let's solve all of this. It should be 0. That means it's balanced. So, substitute nga natin. Let me, substitute natin. What is our TA? We got 169.3 for TA. So, times 4 minus 500 plus our weight is 1177. 7.2 times 1. So, let's sum them up. It should be equal to 0. Negative 169.3 times 4 minus 500 plus 1177.2 times 1. 0 nga. So, equal to 0. So, the values that we got, this TB and TA are correct because we have checked that the system or the structure is in equilibrium. So, let me just show how to do summation of moment at point C. Summation of moment at C equal to 0. So, equal to 0. So, TA is clockwise, evaluating at about point C. Negative TA since clockwise times moment arm nga is 6. Negative si TB and its moment arm is 2. Positive W and moment arm is 3. And then, moment at C. Moment at C is still included and it's clockwise, so moment at C negative siya. So baka sabihin nyo, since, ma'am, why did you include the moment 500 Newton? We're evaluating at C. The moment 500 Newton passes at C. It is actually at C. But why did you include it in the equation? So the answer, kasi that rule is only applicable to forces. No, kasi for forces, you need distance. You need to multiply distance, their moment arm, from the point of evaluation. But for moment, you don't need distance to get this moment. Wala kang i-multiply. Even moment at C or MC is at point C, you will still include it on the equation. Try that. Negative TA 169.3 times 6 minus TB, which is 1007.9 times 2, and then your weight, which is 1177.2 times 3, minus what is our moment, 500. Siyempre, dapat magzi-zero yan. So, calculating negative 169.3 times 6 minus 1007.9 times 2 plus 1177.2 times 3 minus 500. Dapat equal to 0. And yes, it is equal to 0. So, balance ang structure natin. Our system is balanced or in equilibrium. Nadoble. Dinoble ko lang siya. So, let's have this example naman. Let's solve it here. So, let's do the free body diagram first. So, So, you have roller support at point A, and the surface is horizontal. So, your reaction is perpendicular to horizontal. So, it's vertical. This is your RAV. And then, 3 meters from point A is a vertical upward force na 2 kilonewton. And then, 3 meters from that force is a triangular load downward. Topmost magnitude, it is 1 kilonewton per meter. And then, at this point, you have an applied moment, 12 kilonewton per meter. And then the support is a hinge. Since hinge, you have vertical and horizontal reactions. So let's name this RBV and this is RBH. So let's get the value of our supports so that the system is in equilibrium. Okay, summation of forces along horizontal is equal to 0. We don't have forces na applied along the horizontal, so we have RBH equal to 0. And then summation of forces along the vertical, let's get the vertical forces starting sa left side. So all equal to 0. So first force is RAV, upward, so positive. Next, another upward force na 2 kilonewton, so plus 2. And then, at this point, you have a couple, but since you're summing up forces, do not include the moment. So, go to the next load. That is the triangular na. So, get the resultant of this triangular load. It is downward, so negative. So, it is 1 kilonewton meter times, lagay na nga natin ito. So, minus yun na. So, 1 kilonewton per meter times the length kung saan na-apply ang triangular. So, it's just 6 meter. So, 6 meter. Cancel. Natira si kilonewton na lang. So, next, that is your triangular load. Next na load mo is RBV, which is upward. So, positive RBV. Okay, I missed something. For the triangular load, para makuha to get the corresponding force of this triangular load, you just need to get the area, di ba? How do you get the area? It is the length of the triangle, which is 6 meter, times the magnitude or the height of this triangle, which is 1 kilonewton per meter. And since this is a triangle, syempre area niya is base times height divided by 2. So, add divided by 2 there. Okay, so for this equation, we have two unknowns, RAV and RBV. So, let's set this aside and call it equation 1. So, next equation of equilibrium is summation of moment equal to 0. So, pick where you want to sum up moment. So, A na lang din since doon naman tayo usually sum moments. Okay, since we're evaluating point A, any forces that passes point A shall not be considered, and that is RAV. So, let's proceed. 0 daw, equal to 0 daw ito. So, next force is 2 kilonewton. What's the moment arm of the 2 kilonewton? It is, 3. What's the sign? Since point A ang ine-evaluate, the direction of rotation of 2 kilonewton is counterclockwise. So, it's positive. So, next load is moment 12 kilonewton meter. And the direction is counterclockwise. So, it's plus 12. No moment arm since this is already a moment load. Next load is the triangular load na. So, what is the direction? Since downward siya, it rotates clockwise about point A. So, negative. So, how do you get the moment created by this triangular force? It is the same dun sa kanina. Get the area of the triangular force muna. So, that is 1 kilonewton per meter times the base or the length, which is 6 meters, and then divided by 2 or 1/2. And then the moment arm. What's the moment arm? It is 1/3 or 2/3 from the point niya dito. So, what is this 2/3? Let me put here na nga lang. So, what is this 2/3? So, that is 6 times 2/3. Since 6 ito, no? 2/3 of 6. So, this is 2. Este, 2 times 4. Sorry. So, what's the 2/3 of 6? It is 4. So, 2 times 6 is 12 divided by 3 is 4. So, distance of the centroid to this end is 4. So, to get the moment arm of the triangle up to point A, it will be 3 plus another 3 dito, and then yung 4 meters. So, total, 6 plus 4 is 10. 10 yung moment arm niya. Okay, and then next, what's our next force? It is RBV. So, RBV, counterclockwise ang rotation, so it is positive. RBV times, what's the distance? It is 3 plus 6, 12. Okay, so for this equation, the only variable is RBV. So, let's isolate RBV. RBV times 12, then transpose the other terms. So, this one will be positive. You see, 1 kilonewton per meter times 6 times 1/2 times 10. Positive na siya. Then, itong 2 times 3 and 12, they are negative na. 2 times 3, and then 12 is negative. So, RBV is not yet fully isolated. You still need to remove 12 by dividing both sides by 12. So, RBV is now isolated. So, perform the operation to get the value of RBV. So, that is, ano to? 6 times 0.5 times 10 minus 6 minus 12 over 12. RBV is equal to 1 kilonewton. So, let's substitute this to equation 1 to get RAV. So, RAV, let's rewrite the equation. It will be transpose this to the other side. So, it will be negative 2 plus 1 kilonewton per meter times 6 over 2 minus RBV. So, let's substitute negative 2. This will be 1 times 6. It is 6 divided by 2. It is 3. And then RBV is 1. So, RAV is equal to 0. It will not carry any load. So, let's check if this is correct. How do we do the checking? Let's check by summation of moment at B using these values. Using the values of RBV and RAV should be balanced. So, summation of moment at B is equal to 0. So, 0. We have RAV there and RBV here. So, we're evaluating at point B. Consider this fixed. So, RAV, our first force is RAV. Moment arm to point B is 3 plus 3 plus 6 times 12. What's the direction? It is clockwise, so negative. Next, yung 2 kilonewton is still clockwise, so negative. So, force is 2. What's the moment arm? It is 12 minus 3. So, that is 9. Then, next, the moment na 12 kilonewton per meter, counterclockwise, so it's positive na 12. And then, the next one is the triangular load. So, counterclockwise din siya. So, positive. So, what's the value? It is 1 kilonewton per meter times base na 6 meters. Divide mo 2 since triangle siya. And then, what's the moment arm of this triangle to point B? This is 1/3 of 6. 1/3 of 6. So, that is 2. So, what is our RAV? It's 0. Okay? So, since 0 is RAV, all of this should be 0. No? 0 should be 0. To double check na in equilibrium or tama yung sagot natin. So, this whole term is 0. Let's just do the rest. This one should be equal to 0. So, negative 2 times 9 plus 12 plus 1 times 6 times 0.5 times 2. Oh, 0 nga. So, 0 equals 0. So, tama yung nakuha mo. So, for the next example, this one. So, okay. Palabasin natin yung sagot. Let's answer this one. Let's get the reactions of the supports. So, this is a roller. Roller siya. So, and the surface is vertical. So, surface is horizontal. So, RAV is vertical. And then, for point C, it is pinned. So, it can provide vertical and horizontal RCH. Oh, as you can see, we have horizontal load na. So, our RCH have a value this time. So, let's do summation of forces. Let's get this 3 by the 3 equations of equilibrium. So, let's do the first summation of forces along horizontal equals to 0. So, equals to 0 daw. What are our horizontal forces? So, of course, the applied load, 10 kilonewton to the right, so it's positive. And then our RCH to the left, so negative RCH. So, it means, transpose mo yun, RCH is equal to 10 kilonewton. So, tama. Opposite direction sila. Of course, to counteract each other. So, that is our RCH. Let's do summation of forces sa vertical. Ba't summation of forces along vertical equal to 0. So, 0 daw. So, what are our vertical forces? 1, 2, and 3. Tatlo lang din. So, RAV is upward, so positive. So is RCV, upward, so positive. And then, we have a downward applied force na 60 kilonewton. So, this equation have two unknowns. So, let's set this aside. So, let's do the third equation of equilibrium. So, choose if sa A or sa C. Of course, A. Usually naman tayo doon sa left side. So, summation of moment at A is equal to 0. So, equal to 0. So, disregard RAV since it passes point A. So, our forces involved are 60, RCV, RCH, and this one. How much is this one? 10 kilonewton. So, 4, no? 1, 2, 3, 4. So, first load, 60 kilonewton. What's the moment arm? It's 3. What's the direction? Clockwise, so negative. Next, 10 kilonewton. It is clockwise also, so negative. What's the moment arm? It is 6 meter. Huwag niyo sasabihin. Dahil dito, no? This is 6 meter. Perpendicular of the force to your point of evaluation. So, 6 meters. So, 6. Then, next force, si RCV muna. RCV is vertical, upward, so counterclockwise siya, no? So, positive. RCV, what's the moment arm? It is this one, 6 meter. 3 plus 3. So, 6 meters. Then, next load is RCH. But, check RCH. RCH also passes point A. So, you're going to disregard this too. Do not include na sa equation. So, this equation involves only one variable, which is RC. So, we can isolate RC and get its magnitude na. So, RC is equal to transpose. So, magiging positive na sila. Positive 60 times 3 plus 10 times 6. And then, since RC is with 6 pa, you need to divide both sides by 6. So, divide this by 6. So, isolated na si RC doon. Hindi na niya kasama si 6. So, let's do the operation. RC will be equal to, so, ano na eh. Okay, 60 times 3 plus 10 times 6 all over 6. So, RC is 40 kilonewton. And then, RCV. RC lang nalagay ko. RCV to na. Okay, then RAV. Let's get RAV using equation 1. So, let's isolate RAV from equation 1. So, RAV transpose this 2 to the other side. So, positive na si 60. So, positive 60 and magiging minus si RCV. So, 60 minus 40. 20 CRAV. So, our reactions are 20 kilonewton upward, RAV, RCV is 40 kilonewton upward, and RCH is 10 kilonewton going to the left. Let's check. 10 kilonewton, CY is 40, point A is 20. Tama na? 20, okay? So, we got the answers. Next, last na yata to, okay? So, last na to. So, palabasin natin sila. So, let's move to the other slide na lang. So, let's do the free body diagram. So, support at point A is a pin, so it can carry vertical and horizontal. Let's call that RAV and RAH. And then at point B, you have a support, which is a rope, so this is a tension. Let's just call it tension B. So, let's draw the free body diagram. So, first, you have RAV here. And then you have RAH. Then, load. Let's draw the load. This is 800 Newton per meter. And then, TB. TB here, it has an inclination of 30 degrees. Ganyan. And then, don't forget dimensions. Okay. It did not ask for the weight naman. No weight. Okay, let's find the values of RAV, RAH, and TB. So, same pa din naman. Summation of forces, vertical, horizontal, and then moment. So, unahin natin sa summation of forces along horizontal. So, equal to 0. So, 0 daw sila. So, what are our horizontal? Oh, this time, we have two horizontal forces. RAH, and then yung horizontal component ni TB. Okay? So, that is, RAH is to the right, so positive. And then negative si TB. And horizontal component lang, so we need to multiply this by cosine. And the angle is 30 degrees. Yan lang. Okay, so we have two unknowns. We don't know RAH and TB. So let's set this aside. Next, summation of forces, vertical or Y. So equal to 0 din sila, edi 0. So what are our vertical forces? Of course, RAV, which is upward. So RAV, upward. And then we have the distributed or rectangular load, which is downward, so negative. How do we get yung resultant force nito, yung force equivalent niya? So, get the area. Parang yung triangle kanina, we took the area of the triangle for the equivalent force. So, that is 800 height times the length, which is 3 meters. So, you don't divide it by 2 kasi rectangle yan. Nag-divide tayo ng 2 kanina dahil triangle yon. So, this one is okay. And then last, si TB, which is upward. So, positive TB. And then, vertical component lang niya, sine 30. So, this also have two unknowns. So, let's set this aside. So, let's summation of let's sum up moment at point A. Summation of moment at point A equal to 0. So, 0 daw. Edi 0. So, disregard the forces that passes point A. Of course, what are those forces? it is RAH, RAV, and yung horizontal component ni TB. Because, ito yon, the horizontal component of TB. Ito. So, it will pass point A. So, disregard this. Only consider the vertical component of TB. Okay? So, how many forces for summation of moment at A? Only the load and TB. Okay? Yung vertical component. Okay. So, first is the load muna. So, 800. Since rectangular, you get the area first. And then, next, multiply yung moment, moment arm. So, 800 area is 800 times 3. And then, this is already the area. And then, what's the moment arm? Of course, gitna ng rectangle. And that is 1.5, half ng 3. So, this is 1.5, the moment arm. What's the direction about rotation at point A? It is negative dahil clockwise rotation about point A. And then next, TB, upward. So, positive dahil counterclockwise direction. So, the vertical component only, that is TB sine 30. And then, what's the moment arm of this vertical component of TB? 2.8. It is 3 plus 3. So, 6 meters ang moment arm. Okay, from this equation pala, one unknown lang ang meron. So, with this, we can get the value of TB already. Sana pala, nag-start na tayong mag-summation of moment. Dahil may makukuha na tayo agad dito. So, transpose this. So, from negative, magiging positive na siya. 800 times 3 times 1.5. And then, TB, kasi may sine 60 pa dito, sine 30 pa dito, diba? Sine 30 times 6. So, we want TB to be very isolated. So, divide both sides by sine 30 times 6. Sine 30 times 6. So, cancel. TB is now very much isolated. So, perform the operation. Okay, 800 times 3 times 1.5 all over sine 30 times 6. So, that is 1,200. This is Newton. TB is 1,200. And then let's get RAV. RAV from equation 2. We already have TB kasi, diba? So, RAV is the only variable in this equation. So, let's solve RAV. So, transpose all the other. So, change sign tayo. So, 800 is positive now times 3. Negative TB sine 30. So, substitute 1, 2 here since TB is 1, 2. Then, perform the operation. 800 times 3 minus TB na 1, 2 times sine 30. That is equal to RAV na 1,800 Newton. That's our RAV. And then, next, from equation 1, we will be able to get RAH. Isolate natin si RAH. So, sa transpose this. So, magiging positive na siya from negative. Positive na siya. RAH is equal to positive TB cosine 30. So, what is TB? This is 1,200, no? So, 1,200 cosine 30 is 1039.23 Newton. Let's check. Hi, 1039 is correct. That is horizontal at point A, 1039. And then TB, is it 1, 2? TB is correct, 1, 2. And then AY is 1, 8. Yeah, we got 1, 8, diba? 1, 8. And then, of course, merong mga directions yan. RAV is upward. Makikita naman dito sa assumption mo. Okay. Any question, post nyo na lang sa ang tawag dito sa GC. And then, of course, mag-upload tayo ng assignment. And then, next week is midterm week na. Midterm exam week. I don't think makakapag-meet tayo sa Monday kasi parang may exam kayong schedule doon. I check your schedule. Parang tatamaan. So, hindi na kayo makakapag-quiz in this module, but I will include this sa exam. Yes, this is included sa exam. Okay?